I don't want to introduce ourselves, but Marius did that already for me. So we are now both working for Oracle Switzerland. Have been actually working since 2014, and we are in the compiler team for the Java HotSpot virtual machine. So we are taking care of the compilers of the VM, and this is why our talk today will focus mostly on compilation. So before I go into any detail, I have to show you the safe harbor statement, which says, well, what I'm saying is mostly a general product direction, so it's only for you to inform you about what's happening at Oracle, but it cannot be incorporated into any contract, and yeah, you can read the rest for yourself. So if you want, you don't have to take it too seriously, but I try to give you some valuable information about our systems. So what are we going to talk about today? So to better understand it, let me just give a better idea, right? Let me just give you an overview of how a typical computing platform looks today. So there are different layers in there, but the main point here is that we have application software, which consists of what our customers care about, which are user applications, right? And those are typically built on some application framework like Spring or Apache Sling. And we will hear, I'm sure we will have interesting talks about this area later today. So, and this is kind of where Java development, I mean, what a typical Java developer is worrying about these days, right? So user applications and using these frameworks and some other issues as well. Now, what is below? Well, below there is something that we call system software, but the line between these two is debatable, right? But just for this presentation, I decided to draw the line as I did. I mean, system software in our case includes the language implementations, so the standard edition of Java, enterprise edition, and which are all built on top of the Java virtual machine that is running on top of the operating system, which then runs, of course, on some hardware. Now, what person doing Java development doesn't want to care about is what happens here, so in the system itself, right? So it should be actually some kind of a black box, and we people who are working on, like Tobias and myself, who are working on system software, we try to keep the system so that persons doing applications don't really have to worry about what is going on in the system, right? Unfortunately, sometimes it happens that this layer is still kind of a gray box, either because we have some issue, right? For example, the VM crashes with some horrible bug, right? And then you, as your user or actually the Java developer, becomes aware of, oh, there is actually a compiler that sometimes crashes, right? And that's actually bad, and we should actually take care of that. I mean, we are doing working in this area together myself. There's also a different reason why system software is sometimes a gray box. Some developers actually like to look at how the system looks like, right? So they, actually some nice APIs that let you kind of get out more juice of the virtual machine, like for example unsafe, right? You can do some magic with that, and maybe that gets some more performance for you or some other benefits. So in today's talk, we are going to shed a little bit, or we are trying to shed a little bit more light on how the virtual machine works, and we try to talk a little bit about compilers in the Java virtual machine. Now, if you want to keep this system software layer still a black box, then probably this is an ideal time to kind of look at the cookies outside and talk to other people. But if you are interested, then probably it's better to stay here with me. So, yes. So here is the outline of today's talk. The question is, the first question that we try to answer, probably most of you know the answer to, why do we need virtual machines? Then we look at the particular virtual machine implementation, which is the Java HotSpot VM. We look at the just-in-time compilations, some optimistic compiler optimizations, tiered compilation, some recent projects. Tobias will give you some overview of the segmented code cache and complex strings, then the future of the VM, ahead of time compilation, and JVM-CI, Java virtual machine compiler interface, and at the end we'll conclude the talk. So, why do we need virtual machines at all? So if you have some programming language programming language like C, for example, we need a programming language implementation to run that language, programs written in that language on our platforms. And for example, if platform is Windows running on Intel x86, we'll have some compiler, some standard libraries, some debugger, and some software taking care of memory management for that particular platform. You all know that. Now the problem with this approach is that if we have different platforms like Linux running on x86, we need a different set or a part of a different set of language implementation. And the more platforms we get, the more implementations do we have to have, right? And a developer writing C programs has to kind of be aware of the details and of the workings of each particular language implementation. So you do see development a little bit differently than on Windows, than you would do it on Linux and so on. Now the virtual machine, language virtual machine approach, show what the purpose of that is. That if we have, for example, like a language like Java, then we have a language implementation which is the HotSpot virtual machine mostly, and this language implementation and the virtual machine takes care of running your Java programs on all different platforms, all combinations of different platforms that we have, right? And what is nice about it is that the virtual machine actually allows us to run even different programming languages like JavaScript, Scala, and Python on top of the same platform. So you have only one platform that you have to install, and if everything works out fine, this will be actually a black box for you, so you don't have to take care of it. Now, what does an application or a Java developer see of our HotSpot VM platform? So, for example, you can the person could write Java source code like you see there on this box on the left-hand side. So this is a simple loop, right, that implements some variable, and it does this for a while. Now, what happens when you compile this? This is translated to what is called Java bytecodes, and these bytecodes are then given to the Java virtual machine for execution. Now, this compilation, I want to point out, this happens ahead of time, so you compile the program actually before you want to execute it. And what about these bytecodes? Is there any physical chip implementation that execute bytecodes? I'm not aware of any. So this is actually some instructions for an abstract machine that there's no physical chip implementation, and this machine is a stack-based machine, so it's a relatively simple machine. It doesn't have any registers, so and it's actually simple to handle, right? So that the compiler can handle it relatively easily. And these instructions that are for this abstract machine are then given to the HotSpot VM, which is the implementation of this abstract machine. So this is what a Java developer kind of sees of the VM. This is the workflow, part of the workflow. Now, what does VM engineers see out of this? I mean, VM engineers like Tobias and myself. So we get the bytecodes, and these are given then to the VM. What does the VM do with these bytecodes? Well, first we execute them with an interpreter, right? And then the interpreter will probably create some objects which are a heap. It will create also some stack, right? So it's because it creates some threads to run your application. And of course there's a GC which manages this heap, and so on. Now, what the VM also contains is a compilation system. So you don't want only to run your programs in some way, you want to have them running fast, you want to have performance, right? And therefore, we have a compilation system in the VM that consists of two compilers, C1 and C2.